Good morning, students. Today we are going to do question number 2 from June 17, paper 32. It is related to enthalpy, and it says that you are to determine the enthalpy change of neutralization for a different acid from that used in the previous question. The acid is represented by HB, where B minus represents the anion. HB plus NaOH give you NaB plus water. Equation is given. You are provided with FB3. As you can see, FB3 is being provided. You have also, which is your 2 mole per dm cube acid, and you have been provided with FB4, which is your 72 gram per dm cube sodium hydroxide. Your method says read through the method before starting any practical work and prepare a table below for recording your results. Experiment number 1 is, first I'm going to read the whole method for you, and then I'm going to make a table, and then I will start the experiment. So experiment number 1 is, place the plastic cup in the 250 cm cube beaker, pour 25 cm cube of FB3 into the larger measuring cylinder. Measure and record the temperature of FB3, rinse and dry the thermometer, use the smaller measuring cylinder to transfer 25 cm cube of FB4 into the plastic cup. Measure and record the temperature of FB4, add the 25 cm cube of FB3 to FB4 in the plastic cup and stir the mixture. Measure and record the highest temperature reached. Calculate and record the average initial temperature of the solutions. Calculate and record the temperature rise. Empty the plastic cup, rinse it with water and shake it to remove excess water. And then you have to carry out experiment number 2, and this time you have to repeat the experiment or method given for experiment number 1 using 50 cm cube of each solution. Use a larger measuring cylinder for FB3 and the smaller measuring cylinder for FB4, and then there is space for results. Okay, so the first thing which we always have to remember is we have to read through the whole procedure first. We have to jot down our points that what should be included in the table. So when I was reading the experiment, I have realized that I need to record initial temperature of FB3, then initial temperature of FB4. So the first heading is initial temperature of FB3, second heading is initial temperature of FB4, then I have to record highest temperature achieved, then I will have initial average temperature of both the solutions. Initial temperature of FB3 plus FB4 added and together divided by 2 will give me the average temperature, and then I have to record the temperature rise. So there are going to be 5 headings, and there are going to be 2 columns on the right side for experiment number 1 and experiment number 2. So you have to include your data. Always remember, headings are going to be on the left along with the units, and data for experiment 1 and experiment 2 which needs to be recorded is going to go on the right side of the headings. So let's start the procedure. It says, place the plastic cup in the 250 cm cube beaker. We have a polystyrene cup, plastic cup. We are supposed to place it in a 250 cm cube beaker. Now see, I'm placing it in 250 cm cube beaker. What is the purpose of placing this beaker in the plastic cup? The purpose is that your I'm so sorry, your plastic cup is very lightweight. So when you are going to place your thermometer in it and you are going to add your solution to it, you see it can topple. It is unstable. So when we keep it in a beaker, 250 cm cube glass beaker, and we place our thermometer, now you see it has become stable. So what is the purpose of placing plastic cup in the beaker is to provide support to the plastic cup. Okay. Then pour 25 cm cube of FB3 into the larger measuring cylinder. We have larger measuring cylinder. We have already rinsed it in advance so that we can save little time. And I have to transfer 25 cm cube of FB3. Adding 25 cm cube of FB3 into a larger measuring cylinder. You can see it is exactly 25. Now I'm going to pour it into No, it says measure and record the temperature of FB3. So I'm going to place thermometer into this measuring cylinder. I will leave it for a while so that it can attain the temperature of the solution, FB3. In the meantime, so see, if I read it from this side, there are graduations on the measuring cylinder. I will not be able to see the scale of thermometer clearly. So what I will do, I will tilt it this way so that I can read it from the side where there are no graduations. So I'm going to read the initial temperature of FB3, and right now it is, I was holding it at my eye level. If you are sitting, it would be easier for you, and it is 24 degrees Celsius. So the initial temperature of your FB3 is, let me do it again, it is 24. Okay, so we have noted down the initial temperature of FB3. It is 24 degrees Celsius. Let's record it. Okay, then remove your thermometer, wash it and rinse it. As sink is on my right side, so what I'm going to do is I'm going to do it in this beaker so that you can see I'm rinsing it with distilled water. Okay, then using distilled water, I'm going to clean it. It's cleaned, it's ready. Okay, then what I have to do, using the smaller measuring cylinder, transfer 25 cm cube of FB4 into the plastic cup. We have a smaller measuring cylinder now. We have rinsed it in advance just to save the time. So I'm going to add 25 cm cube of FB4. What was FB4? It's 72 gram per dm cube sodium hydroxide. So I'm going to use smaller measuring cylinder and I'm adding FB4 to it. As you can see, it is slightly more. So I'm going to pour it back. Now you can see the lower meniscus is touching the line. Okay, so we have measured FB4. Let's keep FB4 back. Use the smaller measuring cylinder to transfer 25 cm cube of FB4 into the plastic cup. So I'm going to pour FB4 into the plastic cup. So I hold the plastic cup. I'm adding FB4 to it. Measure and record the temperature of FB4. We will keep thermometer in this solution. We can stir it so that we can check what is the temperature. You can keep it in the solution for a while. Nothing is being added. It's just the FB4. So no reaction is taking place. It's just the initial temperature of your sodium hydroxide here. Temperature is stable. It is 23.5. So the initial temperature of your FB4 is 23.5. See that. All right, so the next point is measure and record the temperature of FB4 is done. We have to add, thank you. We have to add 25 cm cube of FB3, which we have already measured. This was 25 cm cube of FB3 to FB4 in the plastic cup, and we have to stir the mixture. It's been added, and now I'm going to stir the mixture. The temperature has gone up, so I have to wait till there is no more change in the temperature. Right now it is 32 degrees Celsius. It's 32. So the temperature right now is, and it's no more changing, it's 32 degrees Celsius. So I will record this temperature, highest temperature, as 32 degrees Celsius. Now see, temperature is recorded to 1 decimal place, okay? So it is going to be 32.0. Now that I'm done with this first experiment, then it says highest temperature is reached. We have recorded it. Calculate and record the average initial temperature of the solutions. You just have to add initial temperature of FB3 and FB4 and divide it by 2 to get the initial temperature, average initial temperature. Okay, you can get this one. And then the temperature rise would be highest temperature minus your initial average temperature. Okay, so we will remove our thermometer. We are going to rinse it. It's ready. We have to discard this solution in the sink. I have washed, I have emptied it in the sink, and then I have rinsed it with water. I have rinsed it with distilled water. Now I'm going to shake dry it. So when you have to dry your cup from inside, you are never going to use a tissue paper. You just have to shake dry it, okay? So that excess water is being removed. Place it in the 250 cm cube measuring your beaker, not the measuring cylinder, sorry. Take your larger measuring cylinder for experiment number 2. Like before, we are going to add 25, we are going to add FB3, but this time FB3 to be added is 50 cm cube. So we have to add 50 cm cube of FB3. Little bit more. It's exactly 50 cm cube. It's ready. What we have to do now, we have to add, place our thermometer in this solution to record the initial temperature. While it's getting ready, I will measure my FB4. How much of FB4? 50 cm cube. But we have a smaller measuring cylinder, so what I'll do is I will add 25 plus 25. So I will use this measuring cylinder twice. It says use the smaller measuring cylinder to transfer 25 cm cube of FB4 into the plastic cup. This time it is 50. So I'm going to transfer it to the plastic cup. First 25 cm cube and then another 25 cm cube. Usually students make error in this part because in the experiment number 1 we have added 25 cm cube using a smaller measuring cylinder, and this time we have to add 50. So they read the method for experiment number 1 and they have to carry out procedure for experiment number 2. So be very careful while you have to use the same apparatus twice for the measurement. Now look at the temperature. It is 23.5. Initial temperature of FB3 is 23.5. Remove your thermometer. Wash it. Rinse it using tissue paper. Dry it. Now what we have to do? We have to take the temperature of our FB4 in the cup. Let's place it in the cup. We have already transferred 25 plus 25 cm cube of FB4 into the cup, and we are going to record the temperature. Right now the temperature is 23 degrees Celsius. If it is visible to you, it's 23 right now. I'll keep it in the solution for a little while so that if there is to be a change, it is being attained, the new temperature. So I'm going to wait for a while. The initial temperature is 23.5. You can see the thread of thermometer is in between the two graduations, so I can read it to half a graduation. So the initial temperature of FP4 is 23.5. Okay. Now we will add both the initial temperatures and we will divide it by 2 to get the average temperature, and we can do it in the table. Now I'm going to add 50 cm cube of FB3 to 50 cm cube of FB4 in the plastic cup. Thermometer is already been placed. Now when we pour it in the cup, temperature starts to rise. You can see this, the temperature is increasing. You can see the thread is moving upwards. You can see there is temperature rise. And what is the temperature right now? It's 32.5. Yes, it is not changing. It's 32.5. All right, so this was the whole procedure for this experiment. Then you have to do the calculations. When you are doing calculations, it says show your working and appropriate significant figures in the final answer to each step of your calculation. Now each is being written in the bold, which indicates that you have to show working in each part, and you have to do the you have to be careful about significant figures also. If you are using 3 significant figures, it will be 3 significant figures in all parts of the calculation. They have already given you concentration of your acid. You know what is the volume, so it's going to be 2 times 25 upon 1000, which is equals to 0.05 moles of your acid. Then the concentration of your alkali is given in gram per dm cube. Convert it into mole per dm cube and find out number of moles in 25 cm cube of NaOH. So the moles of NaOH added are 0.045 and moles of acid added are 0.05. So which one is, if you look at the equation, they both are reacting in a ratio 1:1. So your moles of acid are in excess, okay? Calculate the heat energy evolved in experiment number 1. And heat energy evolved in experiment number 1. Assume that 4.2 joules of heat energy changes the temperature of 1 cm cube of solution by 1 degree Celsius. So what we have to do here, we have to use the formula Q equals to delta T. You will put the values and you will do the calculations, okay? In the next part of the calculations, now I have told you the readings, so you will use those readings and you will do the calculations, and then in the live session we will discuss the answers. Okay, then in the third part, calculate the enthalpy change in kilojoules per mole for experiment number 1. In the previous part, you have calculated heat energy and the unit was joules, and in part 3, the unit is kilojoules per mole. So that means answer to part 2 divided by 1000 will convert it into kilojoules, and then you further divide it by moles and it will be kilojoules per mole. Okay, and then you have to give the sign. Calculate part 4. Now the rest of the calculations, the part 4 and part 5 to be done by you, we will discuss later. Part C1 is the accuracy of larger measuring cylinder is plus minus 0.5 cm cube, and the accuracy of smaller measuring cylinder is plus minus 0.25 cm cube. Okay, so they have given you the error. How much is the error when we are using a larger measuring cylinder and a smaller measuring cylinder? Calculate the maximum percentage error in the measurement of the volume of FB3 used in experiment 2 and the measurement of volume of FB4 used in experiment number 2. So for both FB3 and FB4, we have to find out error in the measurement of volume of FP3 and FP4. Show your working. So how we are going to go about this working? Error in the larger measuring cylinder is 0.5 divided by the volume which you used in experiment number 2 for FB3. You use larger measuring cylinder for FB3 and you measured 50. So it is going to be 0.5 divided by 50 times 100. It will give you percentage error which is equals to 1%. For smaller measuring cylinder, and you use it to measure 50 cm cube of FB4, and you used it twice. Okay, so it is going to be 0.25 times 2 divided by 50 into 100, and the maximum percentage error in the volume of FB4 is also equals to 1%. Next part says suggest a change to the method used in A that would improve the accuracy of your results. So here we were adding volume using a measuring cylinder. Measuring cylinder has a higher percentage error. So if I replace measuring cylinder by a pipette or a burette, graduated pipette or a burette, then it will make it more accurate. Okay, so replace measuring cylinder by a burette or a graduated pipette. Or what else can be done here? If you look at this one, this setup, heat was produced, temperature was rising, and heat was being escaping to the environment through the mouth of the cup. So if I want to prevent loss of heat, what I can do? I can put a lid on the top of the cup. So another way of making it more accurate would be, or to show improvement in the accuracy of the results, what we can do is we can use a lid to reduce heat loss to the environment. All right. So I hope it is useful and you were able to understand what I was explaining here.